Hello everyone. Now in this session we will know about the next unit of a database management system, that one is a parallel and distributed databases. Under that first point, that one is an introduction to a database architecture. In that we will go with the points. That one is an introduction to database architecture. It's a centralized and client server architecture. And then server system architecture, that means a transaction server, then data server and cloud based server process. All the particular server types which means related to a database, because of every server stores the data. Then we will know about one by one. And before we know about the basic about the database architecture, the architecture of database system is greatly influenced by the underlying computer system on which it runs. Architecture of database system is normally depend on the particular computer system. In a particular computer system, the system style, or it may be the which type of system is run. The particular by such aspect of computer architecture as networking, parallelism or distribution. Like computer system on which it run means a computer run on a network, means we can say that that computer in a network, then that one is a network architecture. Then it run a parallelism, or it may be in a distribution system. That's why it's depend on the computer system on which it run. Networking, then one by one, networking of computer allows some tasks to be executed on a server system and some tasks to be executed on a client system. As we can normally say that client server system needs a networking. Division of work have led to a client server database system. Now parallel processing within a computer system allows database system activities to be speed up. With the help of parallel processing, that one is speed the process of a database or database system, allowing faster response to a transaction with the parallel processing, as well as the more transaction per second, execute the more transaction per second. Query can be processed in a way that exploit the parallelism offered by the underlying computer system. It run with the parallelism, offers the parallelism. Now need to a parallel query processing had led to a parallel database system. Definitely if we want to run the parallel query, then we need to run with the that query, parallel query on a parallel database system. That is simply the parallel processing related to a database. Now the third, that one is a distributed database. Then distributed database concept is we store the data across on a different type of sites in organization, allow those data to reside where they are generated or most needed, but still to be accessible for other sites and from other department. Then keeping multiple copies, like a distributed database contains multiple copies, keeping multiple copies in a different type of geographical locations. That one is the concept behind the distributed database. Then the accessibility, or it may be availability of data is better. Then this one is simply the basic about the database system architecture. That one is we can say that networking is a client server, parallelism, that one is a concept. Then the distributed database is concept. Now the centralized and client server architecture. We need to know about the structure of the particular system. Then we can define the database architecture structure. Now the centralized, that one is centralized database system are those that run on a single computer. Normally when we use a single computer as a personal computer, that's called the centralized. Computer are used the single user system and the multi-user system. That one is simply the in a particular single PC we can store create the multiple users login, but the system is a single, or we can say that the centralized. Single user system is a desktop unit. That one is used by the single person. Then multi-user system, typically multi-user system on the other hand has a more disk and more memory and may have multiple processor. serves a large number of users who are connected to the system remotely. Multi-user system, we can say that one is a client server. Without that it is not possible, but for that multi-user it run with the more disk and more memory and have a multi-processor. Now the database system designed for use by single user usually do not provide many of the facility that multi-user database provided. Like a single user and the multi-user, definitely multi-user provides a more facility. Now the single user usually do not provide many facility as compared to the multiple user. They may not support concurrency control. Single user not supports the concurrency control, which is not required when only single user can generate updates. Provision for crash recovery under the single user system is absent. May be maintained with the many consistent of simply making backup of the database before any update, that is under the single user system. This is a scenario of a centralized computer system or the single user like CPU, memory, disk control, USB control and graphics adapter, which one is helps to display the content. Now all the most general purpose computer system in use today have a multiple. We not focus on a single user because of nowadays we use the internet and automatically it done with a multiple or it may be a multi-user systems. Then before that we need to know about the concept that one is have a cross granularity parallelism. If we use a multiprocessor or the multi-user, then definitely it comes with a parallelism. If the multi-user can access the data, then parallelism is happen. Then the concept that one is a cross granularity parallelism. And before we need to know about the granularity means what. In a parallel computing, granularity of a task is a measure of the amount of work which is performed by that task. Granularity of task is measure of amount of work which is performed by that task. Means one task is executed some amount of work, then we calculate that work, that called as a granularity of task. Another definition of granularity takes into the amount of communicated overhead between the multiple processor or the processing element. That one is a communication overhead between the multiprocessor. That one is also a granularity calculation. Now we know about the cross granularity parallelism. In a cross grained parallelism, a program is split into a large task. It's a particular, we have one program is split into large task. It's a task that one is a large task. Due to this large amount of computation task placed in a processor, this might result in a load imbalance. Right? That one is imbalancing about to the processors. It may be some of the processor have run with the large task, or some of the have it may be a null or might be a ideal. That is the problem. With only a few processors all sharing the main memory, database running on such machine usually do not attempt to partitioning a single query. Means when the parallelism done under this, the particular query is not divided. That one is single query is given to the single processor, then as per the query it provides to the particular processor. That query is not divided. That's why individual transaction do not run any faster. Correct? Overall transaction we can say that it run faster, but the individual transaction have not that much speed as under the cross granularity parallelism. Now in contrast, machine with a fine granularity parallelism have the large number of processor, and database system running on such machines attempt to parallelize the single task. Means it's a single task run with the multiple processor, like a query for the example submitted by the user. Under the fine granularity parallelism, program is broken down to a large number of small tasks. It divided into a large number of small tasks Tasks are assigned individually to a mini processor. Single task is assigned to the mini processor. Under the cross granularity, one task is allocated to one processor. That is the basic difference between these two. Now the amount of the work associated with the parallel task is low and the work is eventually distributed among the processor. Hence fine granularity parallelism facilitates the load balancing. Definitely its part is divided into a small task, and that task, a particular task, is assigned to a multiple processor. That's why it manages the load balancing. This is simply the parallelism concept, how exactly it works. Now this is the second type, that one is a client server system. Functionality provided by a database system can be broadly divided into two parts. Under the client server, it's run with the two part, it's a front end and back end. Back end manages access structures, query evaluation, optimization, concurrent control and recovery. Back end, which one is manage the particular database operations or the database related works. Now the front end of database system consists of tools such as SQL user interface. Means when we write a query, then it need a tool, or it may be when we submit the query, it need a tool that calls the front end. And after submitting the query, behind the screen or that the back end, it manage this process, right? Now this is the client server system. This is the client and the server. In between, its network is running. Now the front end and back end, that one is SQL user interface, forms interface, report generation tool, which one is communicate with the back end and generates a output. That one is simply the SQL engine provides output to this forms. Now it's called the front end and back end functionality. The client that uses the ODBC or JDBC interface can connect to any server, right? When the particular SQL user want to connect to the SQL engine, it uses this type of connectivity. Systems that deal with a large number of users adopt a three-tier architecture. The system deal with a large number of users, means millions or billions of users are there, then definitely that system runs with three-tier architecture. We can say that the single user is a single tier, and then client server, it's normal client server, front end, back end. We can say that one is a two-tier architecture. And if the system that deal with a large number of users, that's called three-tier architecture. Under the three-tier, that is application or the web browser, is a tier 1. Business rule or the server, which one is manage that rule, are called the tier 2. And the database, that is tier 3, that's called the three-tier architecture, where the front end of the web browser that talks to the application server. The application server in effect act the client to the database server. That one is simply the business rule is one server, or database, that one is a database which one is contains the data. This is simply the explanation about that is introduction to a database architecture with the point of centralized and client server architecture. Thank you.